All right, today we're going to be looking at Lesson 5 from Algebra 1 in Illustrative Mathematics by Imagine Learning. This is using function notation to describe rules, Part 2, and this is on page 162 in your student notebooks. We start by highlighting the objective for the day, which is let's graph and find the values of some functions. But let's go to an equation to see if we remember how to plug in an input to get the output. What value of Q would make the equation true when P is 7? And so we're going to just do that Q is 4 plus 0.8 times our P of 7. Where did that 7 come from? They asked us to plug it in. So I grab a calculator right now and I do 0.8 times 7. That's 5.6. Oops. And so Q is equal to 9.6. How'd you do? Okay, let's go do it again when P is 100. What is Q when we plug in 100? Pause the video and calculate that. You got it, 84. How'd you do? Okay, those are the input in order to get an output problems. Now we're going to go backwards and solve for the outputs. So what if Q is 12? So this time the 12 is going in front of the equals, and we're solving backwards for P. So this is called an output problem instead. Can you grab a calculator and do 0.8 divided by 0.8? Can you do that in your head? Did you get P equals 10? Pause the video, try the next one. How about if 60 is the output? Notice the 60 goes in front of the equals in place of the Q. Oops, don't do what I just did. Solving backwards for P, we're going to take the same two steps. $56 divided by 0.8 is 70. All right. Which ones did you think were easier, the inputs or the outputs? All right, we've got option A of x equals 60. This is a flat rate plan. No matter what the price is, it's not dependent. There's no x right here with the 60. It's just always $60. Option B is 10x plus 25. That one is dependent on x, the input, which is the gigabytes of data used. So you guys might know this as the unlimited plan, where it does not depend on how many gigabytes, and this one does depend on it on the bottom. Okay, so if a student decides to find the values of A1, well, whatever A plugs in, it doesn't matter, it's always 60, but B does matter. When I plug in 1, it's going to be dependent on plugging 10 times 1 plus 25. Notice that gives us 35. And so it's definitely worth it to be on this plan because it's cheaper if I'm not going to use that many gigabytes of data. So after looking at some of the past bills, she decides to compare, what about 7.5 gigabytes of data? Well, again, no matter what I plug in here, the cost is always 60, but in the plan B, it is going to matter when I plug in 10 times 7.5 and then add that to 25. Well, that's going to be 75 plus 25 or $100. Yikes, that's a lot of money. If this is the case, if I'm going to use that much data, I definitely should have been on the unlimited plan. Describe each data plan in words. And so this is going to be you writing out your own response. Plan A is always $60, no matter how many gigs are used. Plan B depends on the number of gigabytes and is sometimes cheaper than Plan A, could be equal to Plan A, or could be more expensive. Graph the function on the same set of coordinate axes. So imagine that it's always $60. How would I do that? You got it. That's just going to be a nice flat line across 60. That's Plan A. Oops. All right, here's Plan A. Then the other one starts at 10. Oh, I might be getting this backwards. What's our other one? 10x plus 25. I am. So Plan B is 10x plus 25. So our starting, I put the slope on accident. Our starting is at 25. That's my B of the mx plus b. That's my y-intercept at 0, 25. So we start at 0, 25, and then we go up 10 over 1, up 10 over 1, up 10 over 1. And there's our line of increasing values. That's my Plan B. Well, when are the two plans the same? Right here at that point of intersection, in case we were wondering. The student only budgeted $50 a month for the cell phone. She thought, I wonder how many gigabytes of data I would have for $50. So you could look up at the graph, but 50 doesn't land on a corner, so I'm not quite sure. Unless I do the actual calculation, why not go to the algebra and get an exact number and be sure that it's correct? So 10x plus 25 for option B. We're going to minus 25 from both sides to solve for x, and then divide by 10. We get that x equals 2.5 gigabytes. So if I want to keep my budget to $50, I can't go over 2.5 gigabytes. Make sure to explain or show that answer in a full sentence. In order to keep my budget of $50, that would allow me to use 2.5 gigs. On this last section here of function notation and graphing, you are just going to plug in 6, plug in 2.75, plug in 1.482, and then do the output ones. So first we're testing inputs, then we're testing outputs. So take a minute to plug in 6, to plug in 2.75, and to plug in 1.482. And then on these output ones, it means we put it before the equal sign and we solve backwards for x. Okay, take a minute to solve those and then check back in to see if you got them right. Pause the video. Okay, let's see how you did with plugging these in. Again, what should you be doing? You should be grabbing a calculator and putting these numbers in. Pause the video to make sure you can do them on your own, and then let's go ahead and make sure you got these outputs. So when you plugged in 6, did you get 85? How do we say these answers? B of 2.75 equals an output of 52.5. B of 1.482 equals 39.82. Again, given an input, can you get an output? Now there's a couple extra steps on these ones down here. You needed to minus the constant, 25. That gives us 68 equal to 10x because those 25s cross out. And then divide by 10, we get an x or input value of 6.8. How'd you do? Same two steps, minus 25 to both sides. We get 17.1. Divide by 10. We get that the input value is 1.71. Finally, same two steps, minusing 25 to both sides. We get 91.25 equal to 10x. Divide by 10, divide by 10. We get 9.125. Again, what are we solving for? Gigabytes of data. How'd you do on the plugging in and solving?